and welcome to phase 3, that is neural networks. And today in chapter number 3, we'll have a look at neural networks basic concepts for beginners. Now, this has been written by Mr. Jordi Torres, and I will be covering a few more articles given the fact that the way he writes these is simply amazing. He focuses on what is important and gives you a waypoint on what you can start reading about once you are done with this article, right? So let's proceed in a stepwise manner. As always, I'm not going to read it out entirely. I'm just going to read out a few key points that I felt should be spoken about, as quoted by Mr. Jordi Torres. In the same way that when you start programming a new language, there is the tradition of doing it with the Hello World program. In deep learning, you start by creating a recognition model of handwritten numbers. Handwritten numbers that are single digit ones, that is, numbers from 0 all the way till 9. In this post, we will present some basic concepts of neural networks, reducing theoretical concepts as much as possible. Case study: digit recognition. In this section, we introduce the data we will use for our first example of neural networks, the MNIST dataset, which contains images of handwritten digits. But let me tell you, before we reach this level, we'll be working on a few elementary projects, and then we will also start working on a package called Keras, and finally at the end we will work on this particular project, right? The MNIST database, which is the modified National Institute of Standards and Technology database, and the dataset looks something like this, right? They are all black and white images, and very soon we'll write our program on how we can classify these numbers, so that you just have to feed these numbers into the neural network, and on the output end it will tell us which particular number that actually is. Now, these are the lines of code, but it's still going to take us a bit of time because we need to cover each and every aspect of it before we start writing our code for implementation of Perceptron in TensorFlow. So let's get back to the theory. The MNIST database contains 60,000 elements to train the model and 10,000 additional elements to test it. Now you must be thinking, what's training the model and what's testing the model? In a very simple and layman's way, training is more like something that we do sitting in a classroom listening to what the teacher is telling us, and the testing phase is where the knowledge that we learned during the training, we apply it to the test just to see how accurate our model is. Okay, moving further. This dataset, that is the MNIST dataset of black and white images, has been normalized to a 20 by 20 pixels while retaining their aspect ratio. Subsequently, the images were centered on a 28 by 28 pixel, calculating the center of mass of these and moving the image in order to position this position in the center of the 28 by 28. And now I have also opened up a Google search, just showing you how vast this example is as a beginner's example. So you can find all kinds of resources on the internet as well. All you have to do is just type in MNIST dataset. But then again, the chapters that we'll be covering will give you a glimpse of what this actually does, and you can explore further. Moving on. Furthermore, the dataset has a label for each of the images that indicates what digit it represents. That means each of these numbers have been assigned to a label, and therefore a supervised learning, which we will discuss in this chapter. This chapter means the book written by Mr. Jordi Torres. So it's a portion of that particular book which is currently presented as an article on towards data science. Continuing, this input image is represented in a matrix with the intensities of each of the 28 by 28 pixels with the values between 0 and 255. That's the number is given because it's a grayscale image, and grayscale images have a value map between 0 and 255. So that's what this image looks like. Moving further, it is a zoomed out view of what the data actually looks like when the computer interprets. So it's a 28 by 28 points of data. As you can see, all the white areas are given the value 0, whereas all the darkest areas have a maximum of 255. As you can see, at this particular area, it's kind of a light grayish image. That means the value should be far lower than 255, and we can see the representation. These are the values. So that's how the MNIST dataset interprets the images. On the other hand, remember that we have labels, which in our case are numbers between 0 and 9 that indicate which digit the image represents. The position corresponding to the digit that represents the image contains a 1 and the rest are zeros. This process of transforming the labels into a vector of as many zeros as the number of different labels and putting a 1 in the index corresponding to the label is known as One Hot Encoding. I found another link for you to better explain how One Hot Encoding works like. So it's this website called machinelearningmastery.com, and it's run by Mr. Jason Brownlee. Jason Brownlee is a PhD and is a machine learning specialist who teaches developers how to get results with modern machine learning methods via hands-on tutorials. I feel that this website has got a lot of hands-on content to offer. Also, he offers a lot of free crash courses based on different domains of AI and ML. So I would suggest that you start exploring his website. After that, here we are. We are going to talk about One Hot Encoding. I have this particular part which will make all of it very clear. Now consider that we have got 3 colors: red, green and blue. We are associating red with position 1, we are associating green with position 2 and blue with position 3. Now imagine in the MNIST dataset we will have 10 such positions for 0, 1, 2 and so on, and these values will range depending on the kind of position that they are at. Apart from that, there's one more article written by Mr. Jason Brownlee. Here it's a bit more elaborate. Now consider that we have 3 temperature variations: cold, warm and hot. We are representing cold with the number 0, then we are representing warm with the number 2 and we are representing hot with the number 1. Here you can see how cold is placed at position 1, again cold. After that we have warm at position 3, cold again at position, hot at position 2, again hot at position 2, warm at position 3 and so on. I hope that now the example of a One Hot Encoding is clear to you. Again, I'd like to thank Mr. Jason Brownlee for taking the time out to write this nice article for us. Going back to the original article by Mr. Jordi Torres. In the next class, we will cover what Perceptron is, and after that, we'll have a look at something called inputs, the weights, the net input function, an activation function, and specifically this one is called a sigmoid. We'll talk in brief how it acts and the output that we are going to get. Apart from that, we'll also talk about something called backpropagation, which helps us minimizing the error. And finally, we'll have a look at multilayer perceptron, and I am looking forward to give you a hands-on session in the next class itself. So we'll be using Anaconda Navigator, Jupyter Notebook to write code for our first Perceptron model. I hope that you enjoyed today's class as well. See you the next time. Till then, you have a good day.